On. All right, so calculus, there are always 3 calculus questions generally. The first question always has this layout. I'm only going to do this first one. Yeah, this is just basically algebra work essentially, but I think a lot of people don't really practice these questions as much as they should because they think it's very easy and they're definitely going to get the marks, but then you are throwing these marks away. So 7.1 quickly. Determine f dash x from first principles if f of x is 2x squared minus 1. I don't know what time I will be able to post it. It depends on how quickly it uploads. Fortunately, I don't have, I don't have, what's the word, control over that. I will try to start uploading it as soon as it's converted. Oh, and you see where it is on there? Let me check quickly. I am on YouTube here. Let me just go to YouTube Studio. Yes, it is there. It has 141 views already. Lovely. Thanks, guys. And there's one comment. Let's see, what was that comment saying? Try and screenshot. Why is it not clear? Oh, well. Oh, that's a different one. We divide number of months by quarters. Just in time. Yeah, so guys, you can go take a look. I have posted my finance one, and then there's a functions one, and there is also a Euclidean geometry one. So those are the 3 TikTok lives that are posted, and I will post this one as well. Okay, yes, sorry, I didn't say. This is the November 2020 question paper. I am also going to do a question from the November 2021 paper as well. All right, so guys, they've given us f of x is 2x squared minus 1, and they are asking us to find f dash x, the derivative, from first principles. Now, guys, if they didn't ask us to use first principles, right, if we were just asked to find the derivative, we would use the power rule. So we would say 2 times 2, you always take the exponent, you multiply it by the number in front of the variable, so the coefficient. So 2 times 2 is 4, and then you're going to have x to the power of 2 minus 1, right? So you minus 1 from that exponent, and then the derivative of a constant term is always 0. So this is the derivative, guys. This is what we are meant to get when we are using first principles. Okay, that's a nice way of actually checking that we've got the correct answer. Let me actually just get some music back here. I've lost it now. My apologies. All right, so now when we are finding the derivative using first principles, there are different ways in which you can write this. I think some teachers write everything in in fraction form right from the start. I don't like writing a whole lot of stuff in fractions, so I am actually first going to calculate f of x plus h, and then once I've simplified that, I'm going to set up my fraction. Remember that the fraction, the formula for this, is on the formula sheet. You can find it there, and in that formula it says that f dash x is the limit as h tends to 0 of f of x plus h minus f of x, and that is all over h. Right, that is the formula. So we have f of x, we need f of x plus h. All right, so that is why I'm going to calculate that. I'm going to work that out. Now, guys, how we do this is we just replace the x in the original function with an x plus h, and then we simplify it. So I'm going to have 2, and then instead of x squared, I'm going to have x plus h squared minus 1. Now I need to multiply these brackets out. Now, guys, you can either do FOIL, right? So you can write this as x plus h times x plus h, and then minus 1. And you can then FOIL them out. Or if you know the shortcut for multiplying or squaring a binomial, you can do that as well. You will get to the same answer either way. All right, so that is what you will get if you multiply those out, if you FOIL those brackets out, the x plus h and the x plus h. And now I need to multiply the 2 in. So 2x squared plus 4xh plus 2h squared minus 1. Right, that is f of x plus h. Sorry, Keanu. Other people are only writing on Friday. All right, now I'm going to say f dash x is equal to the limit as h tends to 0. Now I'm going to substitute it into this formula. I'm not going to write the formula down again. I'm just going to go straight into substituting, right? So it's this f of x plus h, which is these four terms. So 2x squared plus 4xh plus 2h squared minus 1. And then I am subtracting f of x. Now, guys, because f of x is multiple terms, it consists of two terms, right? We need to put that in brackets. 2x squared minus 1, and that is then all over h. Right? Now what we need to do is we need to multiply that minus 1 into the brackets. If you can, if you feel comfortable enough, then you can do this multiplication in your first step as well. You can say to yourself, there is a minus, and then I have to subtract the 2x squared and the negative 1, so that's going to become a plus 1. But you don't have to. You can do it like I'm doing it as well. So there we have 2x squared plus 4xh, that whole long list of terms. We need to write every single time minus 2x squared plus 1, and that again is all over h. So these questions, yeah, it's a bit of a schlep because we have to write so much stuff all the time. Oh, thank you for all the gifts. That's lovely. All right, now guys, what is supposed to happen here is that all the terms that don't have an h are meant to cancel out. I'm going to say that again. All the terms in the numerator that don't have an h are meant to cancel out. If that is not happening, you've made a mistake somewhere. So we have a 2x squared minus 2x squared. Those two will cancel each other out. And here we have a negative 1 and a plus 1. That is also equal to 0. Those will cancel out. We see now that we are only left with terms that have h's in them. That is very important, guys. The fact that we have an h in the denominator here is a problem, because we are meant to make h equal to 0, right, to get to the answer here. But if I make h equal to 0, I have a denominator of 0. We can't have that. We can't divide something by 0, right? So I'm meant to cancel out this h. I'm meant to get rid of the h at the bottom. The only way for us to do that is if I take out h as a common factor at the top and then cancel it out. So that's why you're meant to get rid of all of the terms that don't have an h in them so that you can take out h at the top. All right, so we're going to say limit h tends to 0. At the top, I'm taking out h as a common factor. Remember, when you take out a common factor, you are dividing by that common factor. So 4xh divided by h is 4x plus 2h squared divided by h is 2h over h. Now guys, it's fine that we have another h in this bracket. We just need that h in front of the bracket so that we can cancel out the h at the bottom. It's fine that we still have an h there. Now guys, if I'm looking at what's left, a 4x plus 2h, if I now make h equal to 0, right, then that whole last term becomes 2 times 0, which is 0. So I'm actually left with only 4x, which is what we know, and we said at the beginning, that is what we are supposed to be getting as our answer, because that is the derivative of this function of 2x squared minus 1 is in fact 4x. So there we got an answer, and we know that it is the correct answer. Now guys, the important thing here is that you can lose a mark for notation. So you need to make sure that you are writing this limit h tends to 0 every time until you get to your final answer, until you've made h actually equal to 0. Then you don't have to write it again, or then in fact you mustn't write it again. Okay, if you write it now at the end in your final answer, they're going to say -1 for notation. And you won't see this note on your paper. Obviously, you're not going to get your paper back, but you will lose a mark there. Same thing here. If you leave it out even once in one of these 3 lines, they're going to take that mark off. So Banele is asking for 1 with fractions. Banele, they never ask 1 with fractions. Okay, so if I look back at I want to say the last 5-6 years past papers, they never ever ask one with fractions. They always ask one with an x squared. So this is what you need to focus on. You need to make sure that you are able to do this x plus h squared thing and then get to your final answer. All right, maybe look at one with fractions if you did one in class, but it won't come up. I'm pretty sure of that. Okay. New examiners, I don't know who the examiners are. The papers are just always very, very similar. So we do kind of pick up over time what you can expect. Sometimes they throw a little spanner in the works there, but yeah. Yes, I'm getting to 7.2.1. All right, guys, next up, we are now finding these derivatives. So like I said, the questions are always the same. It's always a first principles question. And guys, it's also always 5 marks, right? So if you are absolutely sure that you can do these, you will get those 5 marks, which is great. Ntando, I'm not going to be doing optimization today. I'm going to be doing some cubic graphs after these questions. All right, now 7.2.1, they're asking us to find d over dx. Now guys, what this actually means is derivative. The d at the top means derivative, and the dx at the bottom means in terms of x. So that is saying that x obviously is the variable that we need to find the derivative in terms of. All right, sometimes 6 marks, but it's always at least 5. All right, so now I'm going to do this. Oh, sorry about that. I need to find the derivative. Guys, in this whole question, they take off a mark for notation. So you need to be very careful that you are using the same notation that they have used. Firstly, that is important. So you can't now write f dash x, right? You have to say d over dx of this is equal to, you have to use the same notation. Okay, so I'm quickly going to write this down at the bottom. So 7.2.1, they're asking for d over dx. Sorry, my handwriting is very ugly because I'm sitting at an odd angle with this tripod thing. Usually my handwriting is much neater. All right, that is what they have asked us for. All right, so here we are going to look at this. So d over dx of this. Now, guys, the important thing is if they haven't said first principles, we can just use the power rule, right? So the power rule is that if you have this kind of scenario, so you have a number in front of an x and that is then to the power of something, then the derivative of that is n times a. So you multiply the exponent by the coefficient and you then keep that same variable, but you subtract 1 from that original exponent. So this is what we want, guys. We want our terms. Firstly, we want separate terms, and then we also want these terms to be written in this form, where we have a coefficient and we have a variable, an x. In this case, it is going to be an x, and then we have an exponent. So that means that we can't leave this in surd form. We have to write it in exponential form. Now, guys, while you are still working on the expression, right, I'm not going to find the derivative yet. I'm going to change the way that this is written. I need to keep writing d over dx, and I need to keep putting it in brackets. Okay, that's the notation that I was talking about at first. You need to make sure that your notation is correct. Now, using your surd laws, you need to know that if you have something written in surd form and you need to write it in exponential form, which is what we want to do because we want to have x to the power of something, you always take the exponent inside the surd and that exponent goes to the top of the fraction, right? The exponent that you're going to get is going to be a fraction. The exponent inside the surd becomes the numerator of that fraction. The number on the outside of the surd, which in this case is a 5, that becomes the denominator of the fraction. So you're going to have x to the power of 2 over 5. This term is now what we call derivative ready, right? Because now you can apply the power rule to that. Next up, plus x cubed. That one is already derivative ready, right? Because that is written in exponential form. It's fine. We can apply the power rule. Okay, so now we are now ready to apply the power rule. So now we are going to stop writing d over dx. Again, that notation thing. So once you find the derivative, it's the same as up here. Once you actually sub in h equal to 0, right? Once you sub in h equal to 0, you stop writing this limit thing. Once you find the derivative, you stop writing d over dx. Okay, so now we're going to apply this rule. I'm going to multiply the coefficient, the number in front of x, which is currently 1. I'm going to multiply that by the exponent. So 1 times 2 over 5 is just 2 over 5. I'm then going to say x, and this now needs to become to the power of the original exponent 2 over 5 minus 1. So that is going to give us negative 3 over 5. If you're not sure about that, you can use the calculator. Of course, you are allowed to use a calculator. So you can just type in 2 over 5 minus 1. Plus, for the next one, this is very easy. We are, oh, sorry, I'm not sure what happened there. We are going to multiply the 1 in front of the x by 3, which is the exponent. And then we're going to subtract 1 from the exponent. So we're going to get 3x squared. Now we're almost done, guys, not quite. This negative exponent is a problem. We always have to leave our answers with positive exponents. So now we need to move this x to the bottom of the fraction, right? Because if this x has a negative exponent, the way to change it into positive is by moving it to the bottom. All right, but now we already have a 2 over 5. There is already a 5 in the denominator of this fraction, sorry. So we're going to keep the 2 at the top, and this x is now actually just going to be written next to the 5 that we already had. Okay, so you turn that into one fraction. You take the x to the bottom, and there was already a 5 at the bottom. Yes, it is necessary to change it. You lose a mark if you don't. Okay, so whenever you have a negative exponent, always make that exponent positive by moving the x to the bottom of the fraction. Most memos leave the differentiated answer with negative exponents. I've also seen that, yes, but it is a part of the instructions. So I'm worried that they will start penalizing for that. It looks like they haven't so far, but because the instruction is at the top, leave your answers with positive exponents. Yeah, they can penalize you if you don't. All right. How you got to the third step. So this line over here, I'm applying the power rule, which says that when you're finding the derivative, you multiply the number in front of x by the exponent. So here we have a 1 that we must multiply by the exponent to get 2 over 5, and then you take your original exponent and you minus 1 from it. So 2 over 5 minus 1 is negative 3 over 5. Right, so that is the answer, guys. That is the answer for this question, 7.2.1. You don't have to write it in third form again. You can leave it like that. All right, 7.2.2. This one is actually also, yeah, interesting. So they're asking for f dash x again. If f of x is this, 4x squared minus 9 over 4x plus 6. So I'm just going to write that down. F of x is equal to 4x squared minus 9 over 4x plus 6. And then they are also saying that x is not equal to negative 3 over 2. Now, I remember when my matrics this year of 2020, I think this is, when they wrote this paper, they came out afterwards and they were very thrown by this statement. They didn't know what this meant. Now, guys, you're not solving for x, so this doesn't actually matter, right? The only reason why they've written this is because if x is negative 3 over 2, right, if you sub it into your denominator there for x, then it's going to be equal to 0. Then your denominator will be equal to 0. So that is why they've just written it there, because this whole function basically is not defined. It doesn't exist if x is negative 3 over 2. But it doesn't actually change anything, guys. You don't really even have to take it into consideration. You're still going to find your derivative in the same way. Now, what a lot of people also make the mistake of here is that they think, lovely, 4x squared, I can just find the derivative of that. And I can find the derivative of negative 9, and I can find the derivative of 4x and the derivative of 6, right? And then that's my answer. Guys, that is incorrect. Your entire function that you are deriving has to consist of separate terms each in the form of this. If we're looking at this function, this is one term, right? This one term is not derivative ready. We cannot find the derivative of a fraction. If you do AP maths, further studies maths, then there is a rule for that. We call it the quotient rule, that you are allowed to apply. You are allowed to use that in your finals. But if you don't do AP maths, then you have to simplify this fraction into separate terms, each in that form. That is the only way in which you can actually find the derivative of this. So guys, just like in grade 9, you started doing fractions like these, right? Where it's just an algebraic fraction and you must simplify it. You're going to factorize the top and you're going to factorize the bottom, and you are going to hope that you are able to cancel stuff out. All right, so 4x squared minus 9, that is a difference of 2 squares. I'm going to factorize it into 2x plus 3 and 2x minus 3, right? Then at the bottom, you are going to take out a common factor of 2. Hi Kenya, yes, I'm going to have a lesson tomorrow on probability. All right, so I'm taking out a common factor of 2 and I'm left with 2x plus 6. Remember guys, I said this earlier, when you take out a common factor, you divide by that common factor. So 4x divided by 2 is 2x and 6 divided by 2 is 3. Now look at how nice this is. The 2x plus 3 cancels out the 2x plus 3 at the bottom, and we are left with 2x minus 3 over 2. Tomorrow's lesson will be at 4 again. All right, so now I'm just going to write that, but you can also skip this step if you want to. 2x minus 3 over 2. Now, guys, this is not quite derivative ready yet. We still now, remember, you did questions like these actually in grade 8, where you have multiple terms at the top of the fraction, but one term at the bottom. You can now split the fraction up, right? So you can take each term at the top, 2 in this case, and divide it. Put each term over the denominator separately. So we can do this. 2x over 2 minus 3 over 2. What is 2x divided by 2? X minus 3 over 2. All right, there we have a very easy function. This one is very easy to find the derivative of. Now we are going to say f dash x, the derivative of f, is equal to the derivative of just x, guys, is just 1, right? And the derivative of negative 3 over 2, the derivative of any constant term is 0. So yes, Malume, the final answer there is 1. All right, so that is very important, guys. You need to get your function derivative ready before you apply the power rule. If you just find the derivative of every term at the top and every term at the bottom, you will get 0. All right. Stephen, you are frustrated. Why? I'm going to take a sip of my coffee. I don't know if anyone wants to maybe take a screenshot of the screen quickly. How did I find 1? So remember that when we apply the power rule, we take the exponent and we multiply it by the number in front. So if there's no number in front, there's a 1. If there's no exponent, it's also a 1. All right? So 1 times 1 is going to give us 1. And then we're going to say x to the power of, we take the original exponent and we minus 1 from it. That's what the power rule says, right? That's what I've been doing the whole time. So now we're going to say 1 minus 1 is 0. And what is x to the power of 0? X to the power of 0 is 1. So that is why the final answer here is equal to 1. Yes, I'm going to do calculus graphs next. Thank you for the rose. Sorry guys, I'm quickly finishing my coffee. I made it before the lesson started and it's cold now. Okay. Quickly take a screenshot and then I'll go to the next page and then you guys can read through the next questions along before I start doing it. You've been asking for calculus graphs, cubic graphs. That's what we're doing next. All right. We are going to be doing this question. There was a nice little problem solving part here and the last question. The questions before that were not too bad. what happens to the 3 over 2? The derivative of a constant term is always 0, because this is the same as negative 3 over 2 x to the power of 0, because x to the power of 0 is just 1. Right, so that is why for any... Thank you. No, thank you for saying thank you. So that is why the derivative of any constant term is 0, because when you multiply the number in front by that exponent, it's going to be 0 as well. Thank you so much for sharing. Oh, wow, I only saw now how many people are here. 269, that's amazing. Thank you so much all for being here, guys. Tomorrow it's going to be 4 to 5. I won't be late tomorrow. I was just late today because... yeah, our staff meeting ran late. If you came late, it's fine. I'm going to post this to my YouTube afterwards, so you guys can go watch it there. You can rewind, not rewind, is that even still a thing? You can go back, you can pause it, you can rewatch it as many times as you want. My YouTube link, it all is linked in... oh, it's not actually in my bio anymore. The name is just Miss Hanukkah. So my YouTube is not the same as my name on here. My name on here is that maths teacher, but my YouTube channel's name is Miss Hanukkah. Which is, yeah, it's what it says at the top of this page. It's Hanukkah with one N. Alright guys, let's get going on this one. So this is question 8 from the same question, the same paper, the November 2020 paper. So here they've given us the graph of g of x, which is, let me zoom in a bit, I don't think you guys can see there. G of x is equal to ax cubed plus bx squared plus cx, a cubic function having a y-intercept of 0. Now guys, we can actually see that, right? They didn't have to tell us that, but they are telling us that, which is nice of them. The y-intercept is 0. Now guys, that is why in this standard form that they gave us, right, the d value is a 0. Remember, there's normally a constant term as well. In this case, there isn't a constant term. All right, so it was 0. Is drawn below. The x-coordinate of the turning points of g are negative 1 and 2. Right, so they haven't given us the y-coordinates, but in this case, we don't actually need the y-coordinates. All right, so... yeah, I'm worried that if you guys see a question like this, that you might panic because they haven't given you the y values, but you're actually not going to need them. All right, so these questions go from easy to more difficult. The last 2 questions were problem-solving questions, and the first 3 were very kind of routine questions, questions that you really should be able to get. So let's quickly go through them. It's important that you are able to get these marks. So for 8.1, they're saying, for which values of x will g increase? Now guys, an increasing graph, if you remember in grade 9, right, when you started with straight line graphs, we taught you that if your graph has a positive gradient, it's going to look like that. Now then we said m is greater than 0, positive gradient. Now guys, that is an increasing line that we did in grade 9, but the same concept still applies here, right? So this graph is increasing literally where the graph is like moving up. So if we're starting at that turning point all the way to the next turning point, that section of the graph is increasing. So we need to be able to write that in terms of x. Now this is where I think a lot of people struggle. A lot of people are able to see it on the graph, but actually writing it down, I see someone already put the correct answer in the chat, well done. That is where a lot of people struggle. Now, my kids prefer interval notation, which is where you will say x is an element of, and now you need to write from negative 1 to 2. Now guys, we're not going to include negative 1 and 2 because at the turning points, the graph is not actually increasing. At the turning point, what happens is it changes from being decreasing to increasing. And at the other turning point, it changes from being increasing to decreasing. So I'm not going to include those turning points. So I'm going to use a round bracket for that. And I'm going to say negative 1 and then 2. And then I'm going to use a round bracket as well. There is some, disagreement among maths people about whether we should include or exclude them. So you actually will get the mark in finals if you include the x values as well, the turning points. So you actually can use square brackets for these as well. I prefer to say that we are excluding the turning points, but yeah, that is up to you. Just do what your teacher told you to do. All right. You'll get the mark either way. If you want to write it in inequality notation, which is what a lot of people don't like to do, then you will write it like that. All right, so you will put the smallest value on the left, then you'll put the x in the middle, and then you will put the bigger value on the right. Or the best math teacher's surname's Hanekom. Oh, is there another one? I didn't know that. All right, so that is how you would write it, guys. You always are reading this inequality from the inside out. So from x to the outside. So this is saying x is bigger than -1, but at the same time, it's also smaller than 2. All right, let's look at the next one. 8.2. Write down the x coordinate of the point of inflection of g. Now, guys, usually if you have the equation, right? Hello, Jade. Is this my Jade? Now, usually, if you have the equation of the graph, you would make the, oh, it's actually g, sorry. You would make the second derivative of the function of the equation equal to 0, and that will give you the x coordinate, right? But in this case, they haven't given us the equation. So what we need to do is we need to use a little trick, a shortcut, and that is that the point of inflection is always directly halfway between the two turning points. So if our one turning point is at -1 and the other turning point is at 2, the point of inflection is going to be halfway between those two turning points. If you can't find that value in your head, you can always say that you are going to add the two values together. So smallest value plus biggest value, right? -1 plus 2. And then you are going to divide that by 2. So -1 plus 2 is 1, and then we are going to divide that by 2, so we have a half. That is the x coordinate of the point of inflection. Guys, some teachers don't even teach this shortcut because they prefer doing the second derivative equal to 0, but that, in this case, we couldn't even do, right? We had to find the midpoint, essentially, between the two turning points. All right, so that was a half. So this x value here, I'm just going to indicate it, is a half. I still don't know what the y value is, but that's fine. I don't need it. For which values of x will g be concave down? I'm quickly going to erase this highlighted bit here so that I can now highlight the bit that is concave down. Now, guys, concavity has to do with the point of inflection, right? On the one side of the point of inflection, your graph is always concave up, and on the other side, it's concave down. Concave down is like a downwards facing parabola. It has that shape, right? A negative parabola. So that is the shape that we're looking for. And it's always on the one side of the point of inflection. So it's good that we know that the point of inflection is at a half. So it's either going to be smaller than a half or greater than a half. Yes, Amira, like a sad face. All right. So we can see that the sad face shape, the downwards facing shape, the concave down shape is on the right of a half. So we are simply going to say where x is greater than a half. We are not going to include the point of inflection because at the point of inflection, just like at the turning points where it changes from increasing to decreasing or decreasing to increasing, at the point of inflection, this graph is changing from being concave up on the left hand side to becoming concave down. So we don't include that point of inflection. All right. Next one, 8.4. This is now where we have a bit of a problem solving question. So they're saying if the derivative of g, right? Why is it a half and not 2? So 2 is the turning point, right? And they are asking for concave down. Concave down, yes, it is on the right of 2, but it's also this part as well. All right, so for concave up and concave down, you always look for your point of inflection and then it's on one side of it. All right, so it will always be either on the left of a half or on the right of a half. Okay, if g dash x is this, determine the equation of g. Guys, this is a very unusual way of asking us to find the equation of the cubic graph. I'm going to do another example where they've given you points and you need to sub those in. But this is a very unusual way of asking it, which is why it is problem solving. So I'm actually going to write this down. 8.4, g dash x. The equation that they are now giving us is negative 6x squared plus 6x plus 12, right? But we also know that g of x, this is what they gave us, is equal to, I'm going back up to the question quickly, they gave us this equation, right? ax cubed plus bx squared plus cx, ax cubed plus bx squared plus cx. Now from this information that they've given us here, they want us to find this equation. So yes, you could integrate it, but remember integration is not a part of core maths, right? So you only know how to do integration if you do AP maths. Some people are able to kind of visualize, to kind of work backwards, right? So if you find this is the derivative of this, so you can think, okay, what must a be so that when I find the derivative I'm going to get this term. But not everyone is able to kind of do that by inspection. If you are able to, perfect, absolutely, you can just write your answers down. The kind of longer way of doing this is to now find the derivative of this equation that they've given us, right, of g of x here. So what is the derivative of ax cubed? Remembering that a is actually a number, right? I'm not going to get rid of that a. I'm going to leave that a there. I'm going to, and now we are again using the power rule like we did earlier. Let me just write that a little bit smaller. G dash x. So we are going to multiply the number in front of x, which is a in this case, by 3, right? So I'm going to have 3ax squared. That would be the derivative of ax cubed. Now I'm going to do the same thing here with bx squared. It's going to be 2bx. You multiply the b in front by the 2, and then you minus 1 from the exponent, and then the derivative of cx is just going to be c. Now guys, let me line these up for you, and then you can see what we're going to do here. These two expressions are equal. You will get full marks, yes, if you do integration. Absolutely. The teachers that mark have knowledge of that, so they will give you marks. All right, so now, guys, we can see here these two expressions, these two equations, I suppose, are equal. They are both the derivative of g. So that means that negative 6x squared has to be equal to 3ax squared. Those are the 2x squared terms, right? So those two have to be equal. So guys, that means if I do this, 3ax squared has to be equal to negative 6x squared. Well, then that has to mean that 3a has to be equal to negative 6. So yes, someone said there, yes, compare the coefficients. Exactly. You are making the coefficients of x squared equal to each other. This then allows you to solve for a. To get rid of that 3, you're going to divide negative 6 by 3, and the answer is negative 2. All right, next up we're going to look at the x terms. 6x has to be equal to 2bx. So again, if these two terms are equal, oh, sorry, I don't know what this pen is doing. 6x is equal to 2bx. So that means that 6 has to be equal to 2b. So b is going to be equal to 3. And then lastly, this is the easiest one to do. C is going to be equal to 12. The constant terms of the two equations will be equal to each other. So C is going to be equal to 12. Will you get full marks if you just write down the final answer from just looking at it? Yes, you will. Absolutely. All right. So that is a bit of a problem-solving question, but you could also do it by inspection, like I said. All right. And you will get full marks. Yes. Okay. Are we still fine, guys? Wanneer vloek op my live nie asseblief. What were other people asking here? Renee, I do have a YouTube channel. It's Miss Hanekom. I'm not doing grade 10 at the moment, but I will do grade 10 once the matrics are done. All right, let's quickly do 8.5, guys. This is, when I saw this the first time, I said this is definitely problem solving, but they've actually asked this type of question multiple times over the last, I think, 3 years. They've asked it almost every year, either in the final exam or in the May-June exam. How to find the equation by intercepts or turning points. Yes, I'm doing that next. All right, in the next question. That will be the last thing that I'm going to do, because I know people always struggle with that. Okay, 8.5. Determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y equals mx plus c. Someone's asking here, is c not 12x? Remember here it was cx, right? So 12x, so c is 12. All right, so that whole term is 12x, but the actual c value, the coefficient of x, is 12. All right, for 8.5, guys, the key to this question is that they're telling us that it is the tangent that has the maximum gradient. Now you need to think about this. How do we normally find the equation of a tangent, right? We know that it is a straight line, so we say y is equal to mx plus c. Okay, that's the first thing that we do. Then we know, hopefully, that the gradient of the tangent is equal to the derivative of the function, sorry about that squeaky door, at the point of contact. Usually the question says, find the equation of the tangent to the graph at x equals 5 or x equals 2 or whatever. Katalia, I'm busy doing 8.5 right now. All right, so that is what we normally do. We find the derivative, and because it is the derivative of a cubic graph, right, and something an x cubed, that means that there's going to be an x in it. Okay, so we are going to have an x in this expression for the gradient. So then we have to sub in the x value of the point of contact. But guys, if we read through this question carefully, they haven't actually given us the x value of the point of contact, right? Determine the equation of the tangent 2g that has the maximum gradient. There's no mention of a point of contact. I am going to write the equation of g just now, yes, but before we get to that, something that's very important here, guys, is that a tangent that has a maximum gradient, that is the tangent that is the steepest possible tangent that you can get. And guys, that tangent is actually going to be at the point of inflection. So this is not a good sketch because it's not drawn to scale. But that is the steepest possible tangent that you can get. The tangent with the maximum gradient is always going to be at the point of contact. You need to write that down somewhere, guys. Tangent with the maximum gradient is at, did I just say at the point of contact? I mean at the point of inflection. At point of inflection. Usually they tell us what the point of contact is. In this case, they haven't told us what the point of contact is, but they're telling us that it's the tangent with the maximum gradient that has to be at the point of inflection. You have to remember that, guys. Very, very important. Why is the maximum gradient at the point of inflection? Because if you think about this in terms of maximum gradient being the steepest possible line that you can have, right? If we draw a tangent over here, let me just get a blue line. If we draw a tangent there, right? That's not a tangent, over there. Do you see that this blue line is not as steep as this one, right? If I draw a tangent here, again, this blue line is not as steep as this one. If I draw a tangent over there, and what's also very important is that we remember that a tangent always has to be a line that touches the graph at only one point, right? That is also important. This tangent here is again not as steep as that one. Guys, the point of inflection is the point where the graph changes concavity, right? So it changes concavity here at the point of inflection. The maximum gradient is always there. People are asking, where would the minimum gradient one be? If they're asking you for the minimum gradient, it will have to be a cubic graph that looks like this. Right? It will have to be, oh, wow, look at what happened there. root, it will have to be a cubic graph that has a different shape. Then the minimum gradient is still going to be the steepest gradient, but it's going to have the biggest possible negative value. I don't know if that makes sense, right? It will still be at the point of inflection. So they will ask maximum or minimum gradient based on the shape of the graph. I think in last year or 2 years ago, they asked for the minimum gradient. It was again the point of inflection. So what I want you guys to take from this is, if they're asking for the tangent that has the maximum gradient, it's at the point of inflection. If they ask for the tangent that has the minimum gradient, it will always be at the also be at the point of inflection. Yes. So someone is asking here, Cara Marie, do you always use the point of inflection for this type of question? Yes. They always set the question up in that way. And I wouldn't be surprised if they ask this again this year, because they've asked it for the past 3 years. All right. So important, guys, maximum gradient or minimum gradient at the point of inflection. All right, I hope that you have made a note of that. You're welcome, guys. All right, so now that means that this point of contact here, remember we calculated the x value of the point of inflection. So it is at x equals a half. So we are going to find the derivative of the function. That's going to be our gradient, but then we're subbing in a half. So we work with point of contact, and in this question, it's where the gradient is the maximum. Yes, so point of contact, if it's not given, if they're asking for the tangent with the maximum gradient, then you must know that the point of contact is the point of inflection. Okay, that is something that you must remember, please. All right, guys. Now, let me quickly just write here g of x. We haven't actually written that out. Remember, g of x was this, oops, sorry about that, was this equation, but we calculated a, b, and c in the previous question. So g of x is negative 2x cubed plus 3x squared plus 12x. But I'm just remembering now, they've actually given us the derivative already, right? So we don't still have to find the derivative. They gave us that in the previous question. So g dash x was actually equal to negative 6x squared plus 6x plus 12. There we go. All right, now the derivative is going to be, so the gradient is going to be the derivative at a half, at the x value of the point of contact. All right, so we're going to say negative 6 times a half squared plus 6 times a half plus 12. That is going to give us a fraction of some sort. I don't trust myself to work this out in my head now. Let me just double check. I think I have an answer, but I just want to make sure. Okay, 27 over 2. Yes, there we go. That is the gradient of the tangent. 13.5, yes. All right, so our gradient is 27 over 2. So we know that our equation is going to be y equals 27 over 2x plus c. We still need to now find the c value. Now, guys, to find the c value, we need to sub in the point of contact. We had the x value of the point of contact, right? That was the point of inflection. We need the y value. Now we actually can get the y value because we have the equation. So we can now sub that into the equation to get the y value. I'm going to do that quickly. If we say negative 2 times a half to the power of 3, plus 3 times a half to the power of 2, and then we are saying plus 12 times a half, which is just 6. Then we are getting, oh dear, is this right? Oh wait, I made a typo. I typed in a third instead of a half. 13 over 2. There we go, 13 over 2. That is the y value of the point of contact. So we now need to sub that point in. So we're going to say it was a half was the x value, and 13 over 2 was the y value. So I'm going to say 13 over 2 is equal to 27 over 2 times the x value, right? Y equals 27 over 2 times x plus c. Now to get c on its own, you just need to minus that whole term. So c is going to be equal to, let me quickly work this out. I don't trust myself to do all these calculations in my head now. Negative a quarter, there we go. So therefore the equation of the tangent with a maximum gradient is y equals 27 over 2x minus a quarter. All right, so guys, the key to this question was recognizing what we said here. Please remember this. Tangent with the maximum gradient is always at the point of inflection. So someone saying, how did I get y? Guys, if you have to find the equation of a line, right, you need to sub in a point on that line. Right? Now, when you are subbing in a point on this line, the only point that we have on the tangent, remember I'm finding this equation here, this tangent. The only point that we have on the tangent is actually the point of inflection. So we currently know what the x value of the point of inflection is. So we can find the y value of the point of inflection by subbing it in to the equation of the graph, which is this. This is the equation of the graph, right, of the cubic graph. So if I type all of this into the calculator and I put a half in the place of x, then I get this y value. Right, you substitute the x value in the original equation, exactly. All right, so that is where I got the y value from. Now this is my point of inflection, POI, which in this case is the point of contact. Whenever you are finding the equation of a tangent, you always have to sub in the point of contact, guys. How did I find 13 over 2? By subbing a half into the equation of the function. Anita, I'm doing probability tomorrow. All right. I don't have time to redo 8.4 now. I need to go soon, and I quickly want to do the next question. My little girl is going to get home soon, and then she's going to jump on me, I'm sure. I am going to go live at 4 o'clock tomorrow. Mbasa, you're still lost. You find the point of contact, you have the x value of it, you sub it into the equation to get the y value, and then you must sub in that point into your straight line equation to get c, right? That is what you learned in grade 9, I think, finding the equation of a straight line. You always have to sub in a point on the straight line in order to get the equation of the straight line. All right, so that's what I was doing here. I just had to find that point first by subbing in the x value of this function, or into this function. All right, I'm just going to zoom out so that you can screenshot if anyone wants to do that. You didn't have grade 9 because of COVID, hey? Yeah. All right, guys, so let's go on to the last question that I'm going to have time for today. And please do excuse if my little girl runs in and screams, "Mommy," at me. I'll just give her a hug and a kiss, and then I will do the next, and then I'll carry on. So here we have a question with, they've given us one x-intercept and one turning point, and we need to find the values of a and b. All right, all the way to, yes, I am on YouTube, it's Miss Harnacle. All right, so now here they've given us the graph of h of x equal to ax cubed plus bx squared, and they're saying the graph has turning points at the origin O, which is 0, 0, and b, which is 4, 32. A is an x-intercept of h. All right, 10.1 show that a is -1 and b is equal to 6. Now, guys, I did an extra lesson with my own matric class the other day, and they were also asking me about these questions, and they were stressing, guys, the examiners know that these questions are difficult. That is why they always make these questions show that questions, because they know that a big percentage of the country, I suppose, might not be able to do these questions. But even if you can't do this question, you still know that A is -1. It's given there, right? They're telling you, show that A is -1 and B is 6. So even if you can't do this question, it's not the end of the world, because you can still do the rest of the questions, right? They will never just say, solve for A and B without giving you the values. They will always either say, show that A is this and B is this, or they will say, show that the equation is this. All right, they will always give you the values. Now, a mistake that a lot of people make is that they think you can now just sub in points and say, oh yeah, these points work in this equation, so that is why A is -1 and B is 6. You are not allowed to do that, okay? You have to approach this question, you have to do this question as if you have never, or as if these values aren't actually given. As if you are just given this equation and this graph and they're asking you to find the equation. All right, you are just going to check at the end that you actually got these values. I'm not going to do optimization today. I've already said that. All right, so show that A is -1 and B is equal to 6. There are optimization videos on my YouTube, so you can go check them. All right, so I'm going to write down 10.1. They told us that h of x is equal to ax cubed plus bx squared. I'm doing probability tomorrow. All right, so ax cubed plus bx squared. They told us that we have an x-intercept of 0, 0. Now, guys, this x-intercept is also a turning point, right? So that means that it is, I'm just going to say here, a turning point as well. Therefore, this is actually a double x-intercept. I don't know if you guys or if your teachers also call it that. I always say that if you have a turning point or an x-intercept that is a turning point as well, it's a double x-intercept. That means that when you have the equation and it's multiplied out, you are going to have two brackets that will give you this. Okay, but we'll see if that actually is important later on. And then we also have another turning point, which is 432. Now, guys, I think the reason why this is not a parabola, this is a cubic graph, I think the reason why a lot of people struggle with this is because it's almost like there are so many options of things that you can do, right? Because you can either just sub in these points as they are, because they are points on the graphs, right? Or you can sub them into the derivatives, because the turning point is also, that has to do with derivatives, so people feel a little bit confused by this, right? So what I'm going to do, and guys, even me, sometimes when I look at these questions, I don't know how to start. I just try things, okay? I just start subbing in points and I see what happens, all right? So I'm going to sub in, now guys, if we just sub in 0, 0, let me just show you what will happen if I just sub in that point. Remember that h of x is y, right? Y equals ax cubed plus bx squared. I always tell my matrics and all my classes actually, when in doubt, sub in a point. Most of the time you get a mark for just subbing in a point, right? Even if you can't go further. So don't leave this question out. Sub in all the points that you have. All right, somewhere you will probably get a mark. Now guys, what's going to happen if we sub in 0, 0 here? In this case, it's not going to help us because what is y? Y is 0, right? Equals, what is x at this point? It's also 0. So a times 0 cubed plus b times 0 squared. Now that is just 0, hey? So I'm going to be left with 0 equals 0, which is true. I mean, 0 is in fact equal to 0, but it doesn't help us to solve for a or b. All right, so we subbed in 0, 0. It didn't work this time. What if I sub in 432? Let's see what happens. Again, I'm not sure if this is the right thing to do right now. I'm going to try it. Okay, that's also something that you guys mustn't be scared of. You can try things. Maybe you're going to be doing the wrong thing. You can always try something else as well. All right, it's okay if you don't know what to do immediately when you've read a question. Just try something. All right, so the y value of this point is 32. And that is equal to a times 4 squared, right? The x value is 4. Sorry, it's cubed actually, not squared. X cubed plus b times 4 squared. All right. So now we are going to just simplify this. We have 32 equal to 4 cubed is 64, if I'm not mistaken. So 64a plus 16b. Right, we can simplify that a little bit. But guys, bottom line, we still have an a and a b. We actually haven't managed to solve either of these variables. Now, as soon as you get an equation that has two variables, that means that you're going to need actually two equations, right? You need to do simultaneous equations. So the fact that I've subbed in 432 and I'm getting this is telling me that I actually need to set up another equation. Now guys, if we do simplify this, I don't know if you can tell, but we can actually divide all three of these terms by 16. 32 divided by 16 is 2. 64 divided by 16 is 4. I don't know if you guys were aware of that. And then obviously 16 divided by 16 is just 1, right? So we can simplify it to that. That already looks much more manageable, right? And we can already see that if we were to do simultaneous equations with this one and a different one, we could very easily make B the subject, right? Just by moving that 4A to the other side. So I'm actually going to do that already because I know where this is headed. But you only need to do that later on, okay, if you don't realize that immediately. Tabang, I did finance yesterday. It's on my YouTube. All right, so B is equal to that. Guys, if you get to this point, you can already get 1, 2, maybe even 3 marks. All right, a mark for subbing in, a mark for simplifying, a mark for making B equal or making B the subject. Now we need a second equation. We have one equation. In order to do simultaneous equations, we need a second equation. Now we've already subbed in the 2 points that we have into the normal equation of the graph. The other point didn't help me, right? Remember, we got 0 equals 0. Abhishek, there is probably a simpler way. Yes, I am just trying stuff. Okay, I'm just showing you guys that there's often multiple ways of getting to the answer. What about when we are asked to find A, B, and C? Yes, you will use the same approach. Sometimes if they ask you to find 3 variables, one of them will be like the y-intercept, and you can read that off straight away. All right. So now what I'm going to do is I'm going to find the derivative of this. Let's quickly do h dash x. The derivative is equal to 3ax squared plus 2bx, right? Like we did in in 8.4 of the previous question. So ax cubed, I take the derivative of that, plus bx squared, 2bx. Now guys, remember that the derivative is equal to 0. So h dash x is equal to 0 at the turning point, right? We have 2 turning points here. 0, 0 is the one. The other one is 432. So I'm going to sub in 4, right? And see what happens. Remember, h dash x is 0 at the turning point, okay? So the derivative is equal to 0 at the turning point. Now, this only has an x in it, so I'm going to make x equal to 4 because that is the x value of the turning point. So I'm going to say h dash of 4 is equal to 0. Derivative equal to 0. Why are we taking the derivative? Because remember, that's how we find the turning point, by making the derivative equal to 0. They've given us the turning point, so now I can sub it into the derivative equal to 0. Someone's asking where the 3 and the 2 came from. I'm taking this equation here and I'm taking the derivative of that. Right. Inflection is more common name. There is a point of inflection, yes, but I'm not sure what you are referring to. All right, so h dash 4 equal to 0. Now, guys, I'm going to, in this, make x equal to 4, right? Because that's what this is saying. In the derivative, x is being replaced by 4. So we're going to have 3a times 4 squared plus 2b times 4. And the derivative at the turning point is equal to 0. See if that makes sense. See if that makes sense. Right? Derivative. How do we find the turning point? By making the derivative equal to 0. Now I'm making the derivative equal to 0 at the x value of the turning point. I'm going to simplify that quickly, guys. 3 times 4 squared, 3 times 16, right, is 48a. And then this, if I simplify it, is 8b. There we have a second equation. Look how nice. We have one equation there, and we have a second equation there. Guys, for these questions also, what a lot of people get confused by is depending on what you do first, your working is going to look completely different. So someone else was saying earlier, there's a simpler way of doing it. Yeah, maybe if you subbed in a different point first, or if you did the derivative first, then it would have been simpler. You would have had less steps. But in a test or exam, who knows what you're going to do first, okay? Why don't we just substitute b into the original equation, because then I'm still going to have an a and an x. I can't just sub it into the original equation, right? Remember how simplifying or solving simultaneous equations works? You always make one of the variables the subject in one of the equations, and then you sub it into the other equation, all right? You can't sub it from an equation back into that same equation. You always have to go to the next equation. Amy, just do as many past papers as you can basically, but start by working through the most recent ones and work your way backwards. All right, so now I'm going to make b equal to 2 minus 4a here. So I'm going to say 48a plus 8 times b, which is 2 minus 4a, equal to 0. All right, now we see that we have an equation with only a's in it. So 48a plus 16 minus 8 times 4 is 32. So that is 32a is equal to 0. We have 48 minus 32, which is 16a. And if I move this 16 over to the other side, it's going to become negative 16. And there we are getting our negative 1 for a, right? That they asked us to get. They said, show that a is equal to negative 1. There we have it, right? We got to the correct value. Now, once we have our a value, to get our b value, we need to go back to the previous equation where we made b the subject, and we need to sub that a value in. So now we're going to say b is equal to 2 minus 4a, right? But a is now negative 1. So this is going to give us 2 minus 4 times negative 1, 2 plus 4, right? So 2 plus 4 is 6. And that is also what they asked us to get in the question. Show that b is equal to 6. Now guys, I saw some questions. I saw someone asking, why did I not in this line make it equal to 32, right? And that is a very common mistake because the y value is 32. But guys, what I'm subbing it into here is not just the it's not just the equation of the graph, right? I already subbed 432 into the equation of the graph. There I made x equal to 4 and y equal to 32. This is something completely different. Here I'm saying that I'm taking the derivative and I'm making it equal to 0, right? Where is the derivative equal to 0? At the turning point. So the turning point is 432. But guys, when you calculate your derivative, right, this is the derivative that I'm talking about, this 3ax squared plus 2bx, there's no y in this. There is only 2 x's, right? So when you are subbing in your turning point, which is, yes, 432, there's actually no place for you to put the 32. There's only a place for you to put the x. All right, so 3a times 4 squared plus 2b times 4 is equal to, what is the derivative equal to 0? What is the derivative equal to at the turning point? 0. Okay, guys, some of you were asking if you could use elimination. Can you subtract the two equations? Absolutely, yes. You can solve for a and b here in whichever way you want to. I like substitution. I usually use substitution, but you can subtract the two equations, absolutely. You also could have made a the subject here. Someone was asking, will you get penalized if you make b the subject in both of them? Absolutely not. No, that will be fine. You can make b the subject there and then make them equal to each other. That will be absolutely fine. All right, you can get that. Okay, guys, I need to get going now. I hope that this was useful. I am going to post this live on my YouTube as soon as I can. Ntando, I am going to be doing trig on Friday afternoon, 3:30 to 5. I have already done some Euclidean geometry. I did that last week and it's on my YouTube, so please go watch there. Guys, I'm doing probability tomorrow. Zunaid, oh, I'm sorry, I have to go now, but I'm going to post it on my YouTube, okay? So you can watch it there from the start. Thank you so much for being here. Thank you for interacting, for sharing, for following. I really do appreciate it. I am going to see you guys tomorrow afternoon at 4 for some probability, some counting principles, some of the other probability questions that come up all the time. And yes, hopefully we can ace maths on Friday. Just one last thing, guys. If you weren't here from the beginning, we are running a discount code on the cheat sheet. If you haven't heard of the cheat sheet, go onto my page now and go watch the videos. It is an amazing resource that I worked on for like 6 months. Blood, sweat, and tears went into writing that book. So it is a paper 1 book is about 104 pages. I think the paper 2 book is 110. That is the discount code. My little girl is walking in right now. I will see you guys tomorrow. Hello.